Hello and welcome to AP Computer Science with the Arupe Virtual Learning Institute. My name is John Maxwell. Last night in class we went over EIMACS Lab 3 and we'll do it again in this video. So we're looking at an IMAX screen, task 3.1, and in general I'll describe that we're going to create a card class, a hand class, which is a hand of cards for playing, and a deck class. We'll follow the instructions in the IMAX Lab 3. And hopefully, with a couple of pauses and reading and stopping, you'll be able to submit at a later step a completed project. So we have task 3.1 before us, and we have a card class, and they say first and most straightforwardly, we need accessor methods for get suit for the my suit and my value fields. And we also need an image file name that returns the file name of the image that will be used when we display the card in the graphics window. So don't worry, you don't have to know anything about graphics. They're going to give it all to you. And it's not part of the AP exam, but it makes the project more interesting. This project is largely about array lists, although we'll start out with an array of card names beginning at deuce and ending at ace. So we have deuce 3, 4, 5, 6, 7, 8, and these are strings, and the values are an int from 2 to 14. And so when you create a card that's the 2 of clubs, for example, it will have the value 2, and then the suit will be clubs. But that card is accessed at index 0 of the card names. Notice that. Okay, so I'm not going to really do my work over here. I'll do it here. And it says, take a look. We have card names and we have a number of things, constructor. We have a name method that returns the name, and they want us to return suit, which would be a string, okay, and it's get suit, and it would return my suit. And if you've taken some time to familiarize yourself with the class, maybe by pausing, a card is designated by its suit: hearts, diamonds, clubs, spades, and a value, 2 through ace. And likewise, they tell us to return a int get value, and I'll spell it right, get value, and what we'll do is we'll return my value. That's pretty easy. Accessor methods are what you're familiar with. Now we want to find out about a image file, and I want to point out that the image files are all here. So there's the 2 underscore of clubs, and it goes all the way down to the ace underscore of hearts dot png. Okay, so we can understand that we have the images that were downloaded with the file later on. So you're probably working in IMAX to complete this. So, eventually you're going to want to have it over here in either Visual Studio or Eclipse. All right, so let's come back here and say this is something we want. public string image file, and I'll just copy that because I'm incredibly lazy, and I'll put it right here. And it returns a string, and the name of the file is image file. And so what we want to do is return, come on, all right, and that would be in the case of that, take a look, I'll just paste it so I don't waste your time. If the value is less than 11, okay, why? Well, we have an array of 13 elements, 14 cards, let's see, sure, 6 and 7 is 13, and they're stored in 0 through 12. Notice how this works, my value minus 2. In other words, when we are looking for the deuce or 2 of clubs, we'll find that in the 0 position of the above array card names. And so we can just access my value. But that doesn't work for the face cards. So what are we going to do? What we want to do is go ahead and use that same logic up above to get the value at my value minus 2, and then convert that to a lowercase. So that is the card class in a nutshell. Now you can take this code and put it into EIMACS and run it if you wish. So let's move along and go to the next section. Complete the definition of the deck class by doing the following: providing a body for the constructor so that it initializes my deck to an array list of cards, comprising 13 cards 2 through ace for each of the 4 suits given in the suits array. And you can see the suits array down here. There's a suits array with 4 entries, the suits of a typical deck: spades, hearts, diamonds, and clubs. The next thing we want to do is design a shuffle method that rearranges the order of the cards in my deck by performing an operation a large number of times, say 500, by choosing a random index 0 through 51. That makes 52 cards. Using math.random, remove the card from that index in my deck and then add it at the end of the array list. And then we want to deal a card, which removes the first card from my deck and returns the removed card. If the deck is empty, print an error message. So let's go to the deck class. Okay, so I already have the constructor done for you. Where I do is initialize my deck to be a deck of cards 52 in length, storing at positions 0 through 51. And then I iterate through all the suits up here, and starting at 2 and ending at 14, okay, I'll add a card to the deck that I kind of create on the fly, which is given the suit and the value. Okay, and that corresponds to the constructor that we saw in the card class, taking first suit and then value. Well, now what we want to do is shuffle the deck, and it's probably not going to return anything. It's just going to, rearrange it. And it tells me that what I want to do here is, um, do it a lot of times. They suggested 500. So I'm going to repeat that operation 500 times. And anything in that loop is going to run. Okay. And then they tell me to take a random number. And what I'll do is I'll generate a random number. Okay. Let me generate a random number in a moment. Let's call it rando. And it's kind of well and wise to stop here and talk about math.random. Students last night correctly identified that math.random returns a value between 0 and 1, non-inclusive of 1. So it could be 0.0001 or it could be 0.9999. So if you multiply 0.9999 times 52, you're going to get something like 51.999, really close to 52, but not 52. And then if you cast it as an int, that truncates the 0.99 and you get 51. And likewise, if you multiply a value that's returned by math.random as something like 0.00001, okay, times 52, you're going to get a very small number, and when you cast it, you'll get 0. So that's how math.random works, and you're sure to see it on the test. And so what I want to do is my deck.add tells you to add, and it'll add at the end of the deck. My deck.remove. What are we going to remove? Rando. Okay. So we'll remove a card and stick it at the end, and we'll do that 500 times. And then the deck is shuffled. Okay. Now it may move the same card a couple of times. Okay. That's something that could occur, but we'll not think about that now. Okay. So now what we want to do is deal a card, and it says return the first card in the deck or null otherwise. So let's just go there, public, and what will it return? Card. Okay. Deal card. And what we'll do, we'll test if my deck dot, and I'll have to type it the way it's been typed, dot size. And it's important not to use length or to confuse array lists with arrays and start using array notation. What do we want to do? If it is bigger than 0, okay, what we'll do is my deck dot remove. Okay, and we'll remove at the beginning of the deck, which is what they ask. Okay, and we'll just do that. Okay, and they really don't like the idea of size greater than 0. Okay, what they want us to use is empty, and I'll tell you that that's fine if you want to use it. It's just not one of the methods that are part of the AP exam subset. So we'll do it that way. And then else, they want me to say to you, okay, null. And I think I should let people know systemout.println, and then just say deck empty or delt, and then they say return null. And we'll remember that null is an object that's never been created. So when null gets returned, you can somehow, wherever that method is called for, we can handle that null outcome. All the cards have been dealt. And you can either create a new deck and shuffle it, and or stop the game, however it goes. Well, I feel like that's pretty much what we need for the deck class. Let's move over to hand. And with hand, okay, they pretty much want us to do it completely. And it says the hand is stored as an array list of cards in a field called my hand. It has initial capacity of 5 that's set in the constructor. It has a get hand method that returns the my hand array list. It has an add card that takes one argument, a card object, and adds it to my hand. And it has a print hand instance method that prints out the names of the cards currently in my hand, each on a new line. Okay, so you can kind of see this, right? And eventually the code that we'll write over in Visual Studio Code, you know, you'll be putting into the EIMACS task 3.3. So let's continue a little bit on hand, okay, and say we'll start with the idea that it is a private array list of card objects. And what did they call it? My hand? Yeah, I like that. Okay. So then what we want to do is create the constructor, which is going to initialize that to 5 cards. And we know from the past that it will share the same name as the class, and it will have the same name as the file, hand.java. So my hand equal new array list. Notice also that all the import statements and package statements work out of the box, okay? And I'll just put card. And another one that you probably won't see on the exam, but we can specify the size as 5. So that's useful. That's the constructor for it. What else do we do? We want to get hand, okay? So let's make it public, sorry. Public, it'll return an array list if it's going to get an array list. An array list of card, if you leave that out, you'll have a problem like I had last night during the class and solved this morning, okay? Get hand, and it'll return an array list, and guess what? It'll return my hand, okay? And that satisfies the return requirement there. And then it's called get hand, yeah. Okay, we're doing pretty good. What else do we need? We need to get print hand. Okay, I think they said that. Public. And I did that mistake last night and someone corrected me. Somehow I never can seem to type this properly. Public. Print hand, it's just accessor method, and we'll go through using the for each loop in this case. through each element of my hand, and that will be for all 5 elements if it's full. Okay, and we'll system dot out dot println c dot name, and that's a method in the car class. Okay, so I believe I've fulfilled all the requirements here: an add car, to print hand, a get hand, initial capacity. Let's see if I made any typos. We'll go through lab runner 3, and it add card. Well, I didn't finish up add card, okay, which is public, okay, void add card, and it will be card C. And what do we want to do here? Well, we want to give it a little more space as we add the card, okay? And I'm just going to, at this point, go my hand dot add C. All right, a little later we're going to switch this up, but let's run it now again. We forgot that add card. I love it. Okay, you can see it too. You can see the poker hand here. There's some interesting stuff coming after the required portion of the lab. And obviously, we showed you nothing of what, you know, actually generates the display of the cards in the screen. So you can assume that all that's given to you, but you do need to carefully follow directions by copying and pasting code into places of files like hand panel or lab runner that the EIMACS Lab asks you to do, and be careful, okay, and place it in the good places. All right, there is another task that you need to complete before you get to the lab checker. So this you could consider just a start, the first 3 steps on the way to 27 points, right? But hopefully it will give you a good start and you'll be able to handle it from here. Reach out if you have any questions, and thank you for watching.